Hello everyone and welcome to the Unreal Engine 5 and WWise video tutorial series. In this video, we will implement game parameters aka RTPC on events we created before. I will show you two examples of this. One will be icicles adaptation in time by an overdrive effect, and the other one will change the music playing in the background by the help. Let's start with the WWise project. I organized the project a bit and assigned the parent actor mixer for icicle sounds. I'll put an overdrive effect on this actor mixer, then I'll control the dry wet level of this effect by an RTPC. Same RTPC also will increase the gain of this actor mixer. Go to Game Sinks, under Game Parameters, create one game parameter for icicle cast time. I limited the values between 0 to 5 because I want to track that skill's cast time up to 5 seconds. Then I changed the interpolation to skew rate for smoother value change. In RTPC window of icicle actor mixer, you can choose which internal parameter of this mixer to control by an RTPC value. I'll use makeup gain for this implementation. After connecting X and Y axis, a graph will be appeared. This graph lets you design your selected characteristic of the actor mixer and the RTPC value. As you can see, it's between 0 to 5, and I want to control makeup gain between -2 and +2. You can change the graph by moving the dots on the graph or double click on the line to bring another dot to design. When we play any sound under this actor mixer, you can notice the output volume will change when we increase the RTPC value. The approach of assigning RTPC is like that. You can add more members to control with the same RTPC. Like, I'll attach that to the overdrive effects wet dry mix level. By that, two bindings of the same RTPC, when the value goes near to 5, both the gain of actor mixer and the mixed dry level of overdrive will be increased. So I'll achieve something louder and more harsh. The idea behind it to make skill sound more powerful and extreme in time. This was the first example of the RTPC implementation. Now let's do the second. I'll create a heartbeat sound and it will be hearable when the character's health goes under certain amount. It will also decrease the volume of the team playing behind. Follow the previous process. Create an RTPC, assign this value to certain characteristics of the desired sounds, which are heartbeat and game time. Then adapt these RTPC graphs. For my adaptation, whenever we go under 40, theme will decrease in volume and heartbeat will increase at the same time. And under 10, these sound levels will be fixed. As the heartbeat RTPC graph, do the opposite for the theme song. Now it's ready to go. Create an event for the heartbeat, then put it on the sound bank and generate. Instead of creating event for heartbeat, you can also assign that to game theme event, but it's somewhat better to separate them for now. Go to Unreal Engine and generate sound. You will see an asterisk on updated events. Also at Wise Picker, find the game parameters you created to be sure. Alright, go to Jukebox Blueprint then post the heartbeat event. I posted in here because it's a 2D sound and somewhat similar to game theme. It is optional to reset RTPC value, you can do it or don't, just to check before playing with RTPC values later. Then go to wizard characters blueprint and update the health parameter with character's health. Simply call set RTPC value node in event tick and update the parameter with our character's health. Since that RTPC value being used globally, it doesn't depend on which character updating. You can leave the actor input empty. Let's check the gameplay if it works. Now we can transform the blueprint code we written to CPP code. Undo the things we have done in blueprints and go to jukebox CPP class and post heartbeat event at begin play. After this, go to wizard character CPP class and set RTPC value by the health of this character in tick function. Like some other functions we already used in the project, set RTPC value also works in two ways, either by the WWise specific RTPC value or the name of the RTPC value. We will go with the name string and tweak the function with our parameters. Leave WWise specific value to null. For float value, use our health value. Leave interpolation time with 0 ms. You can use some values in here, but we already designed our RTPC with skew rate, so leaving it will be just fine. Use the name of the RTPC as the last parameter. About actor parameter, it's a question to ask. Do I control a global RTPC or local RTPC? If an RTPC is assigned to multiple actors, there can be individual users and we use a specific actor while setting the RTPC. But if it's global or unique, we don't have to specify an actor. For this use case, game team and heartbeat is global and unique, so we don't need to use an actor value, so leave it null PTR. Let's compile the code and give it a try. It worked as blueprint implementation, so the code transfer has been done without a problem. Now we will extend our RTPC scenario with the ice skill we cast. Go to wizard character CPP class and create a private variable to hold how long we have been casting the skill. Initialize this variable to 0 at the start and when we cast spell. We will update the RTPC value while we casting the spell, so it's under the tick function and while we have mana to cast. Parameters of the function is similar to previous example. No WWise specific value, use the name of the RTPC as string, and feed it with the float value. But in actor side, we shall define the actor now, which is the class itself. Why we do this? Imagine multiple wizard characters in game and you updating RTPC values globally. that will change every other character's RTPC value too. So you should do this locally or for only your character. Update the ice skill cast time value and time by the delta time value of the think function. I also want to print current RTPC value on the screen. For that, we use getRTPCValue function. It has a detailed usage which we won't use, but get the RTPC value only. So add these temporary eRTPC value types as placeholder and create a temporary float value to get RTPC from the WWise system.
This recording was made with microphones built by WWise from Offshore Acoustics. These are incredible microphones that were built in the late 90s. And they've been refurbished several times, and they really have an incredible frequency response, and they have a range of 6 miles around the belt. So everything that you hear on these recordings is a resonance within a 6-mile radius from the place where I was recording in Venturas Bay, Mexico that night.
Let's compile the code once more and try our game. You can see the value change on the screen and also hear the harshness of our ice skill in time. I have one more way to show how our RTPC values change in Profiler. Go to WWise project, under layouts, open Game Object Profiler. Activate Voice Inspector data and inactive game syncs at profile settings. Go to Views and open Soundcaster. Find the RTPC you want to expose, right-click, under Profiler choose Set as Object Filter. You can see the RTPC name at GameSync monitor now. Play the game while profiling on and see how the RTPC value changed in gameplay. Do the same for health RTPC and you will observe the same monitoring. Alright, that was it for this tutorial. As you can observe in the profiler, our RTPC values being updated correctly and the game sounds interpret these changes. We have implemented two RTPC usages in game, one for local and one for global. Both Blueprint and CPP implementations gave us the same result. Thanks for joining me on this episode. If you have anything to ask about it, feel free to comment under the video, and have a good day.